Hi everyone, today I'm looking at a question from one of the past year A-level papers and this is a question that students often say that they have difficulty visualizing what's going on. Okay, so I'm going to do some animations to help you visualize. Okay, so this is from Physics 2017 paper 2, question 2B part 2, right? The question goes like this. We have a space probe that's on the surface of the planet Pluto, okay? And it's looking at the moon, Charon, over a time of several days. Now, the fact that Pluto is the planet and Charon is the moon was stated earlier on in the question, okay? The question wants us to suggest what the space probe observes as a result of, number one, that the period of rotation of Pluto is equals to the orbital period of Charon. Okay, now this one is quite simple, quite easy to visualize. Now we have Pluto. Pluto is rotating about its axis like this, and then we have Charon. Charon is doing its orbit like this, right? So many of you will recognize this as being very similar to what we learned about geostationary orbits. Okay, so the animation will look something roughly like this. Now I'm using a picture of the Earth and the Moon because I couldn't find a suitable picture of Pluto and Charon, but you get the idea, okay? So we have the Earth over here rotating about its own axis and the Moon making a circular orbit around the Earth. And both of these rotations, the rotation and the circular path take the same amount of time. So what you can see is that the moon is always above the same point on Earth, right? And that's what we call geostationary orbit, okay? So shall we put that in the answer? Well, yes and no. So for the answer, right, I would say a safer way to answer this question would be to say that the same side of Pluto always faces Charon. Now, why didn't I say geostationary orbit? Now, there was nowhere in the question that says that, Pluto orbits exactly above the equator, right? And we know that that is one of the criteria for a geostationary orbit. Okay, so what we can say is that the same side of Pluto always faces Charon. Okay, so you have a look at how this plays out in this animation again. Okay, so the same is just like saying the same side of Earth always faces the moon. Okay, from this animation. So like this side of Earth always faces the moon, like that. Okay. So the next part is the one where everybody gets kind of confused. It says that there are equal periods of rotation about the axis for both Pluto and Charon. So now not only is Charon moving in a circular orbit, Charon is rotating, spinning around as it moves in a circle. Okay? So what do we mean by Charon spinning around? It will be something like this. Okay. So the moon and the planet both spin, but we are going to add one more thing, which is that the moon, while spinning, also makes a circular path. So now the difficulty that everyone faces, right, is that three of these things, right, the two rotations plus the circular motion all have the same period. Okay, now if you have difficulty handling like these three facts at the same time, right, it would be beneficial for you to like write them down. So you have Pluto's rotation, Charon's orbit, and Charon's rotation. Okay, 1, 2, 3. All these three things, same period. Okay, so let's see how that pans out. Okay, so now notice that the moon that I have here, right, that's supposed to represent Charon, is also rotating as it is spinning. Okay, and if it takes the same amount of time, it ends up like this. So not only does the same side of the planet always face the moon, now the same side of the moon always faces the planet as well. Okay, so in astronomy terms, this is known as tidal locking. Okay, but this is of course not in syllabus, so don't be too worried about it. Okay, so how do we phrase this in an answer? We just phrase it the same way as the first part. The same side of Charon always faces Pluto. Okay, actually what this means is that Pluto and Charon are tidally locked to one another. So that was quite a low quality animation. Let me show you a slightly higher quality one. So this one is actually made from pictures that NASA take of Pluto and Charon. Okay, so if you look at a simulation of what they're doing, they are actually just orbiting each other, but they are always facing one another like that. Okay, the same side of Pluto always faces Charon and vice versa. So we can see here, this is the moon Charon. Okay, and then now if we take Charon's point of view and look at Pluto, yep, you can see that it's rotating. Charon is rotating to look at Pluto all the time. Okay, so now we are looking at Charon, and you can see that as Charon rotates, it kind of matches its movement around Pluto, right? So it's like they're always facing each other as they do their orbit. Okay, so I hope you found that useful, and I'll see you in the next video. Okay, thank you everyone. Bye bye.